Welcome, stargazers. Might you at any point trust it? Picture a heavenly event so huge that it creates shaded areas on Earth, apparent even without trying to hide. That is the scene we may be near the very edge of seeing. In the Orion constellation, the star Betelgeuse is acting strangely, indicating a looming cosmic explosion that will illuminate our sky more than ever. However, when will Betelgeuse go supernova and what will it look like? According to researchers, what secrets could this heavenly event uncover? Join us as we plunge deep into the details of what's actually the deal with Betelgeuse and the effect it could have on Earth, and maybe for the whole nearby planetary system. Found around 650 light-years from Earth in the Orion constellation, Betelgeuse isn't just any normal star. It's a red supergiant, quite possibly one of the most glowing stars known to us, shining with a brilliance over 100,000 times that of our Sun. But why does this red giant matter so much to us? Well, Betelgeuse stands out not only for its brilliance but also for its history and importance in human culture. Named after the Arabic expression Yalala, which means the hand of Orion, Betelgeuse has been noticed and documented by ancient civilizations for hundreds of years. It has been a guide for travelers and a mark of wonder for astronomers, with its ruddy shade distinguishing it from other stars in the Orion constellation. Can you imagine a single star overshadowing our whole solar system? To give some perspective on the sheer immensity of Betelgeuse, if it replaced our Sun, its edges would extend all the way to Jupiter. How could a single star achieve such huge proportions? A mere 10 million years old, it's significantly younger than our 5-billion-year-old Sunday. However, Betelgeuse's enormous size means it burns through its material much faster, predicting a shorter life expectancy than that of other stars. Now this celestial behemoth, traversing a volume big enough to contain more than 1 billion of our suns, is approaching its final cycle. When stars of such size reach their twilight years, they don't just disappear. They exit with an extravagant flare. A cosmic explosion, a blast that is beyond human understanding in terms of its energy and brilliance. Such an event has the potential to dominate a whole galaxy, creating shaded areas of brilliance across vast distances. The last time Earth saw a supernova blast this close was in 1964, sometime before the development of modern telescopes. This event, known as the Kepler supernova, was the last supernova to be seen in our Milky Way galaxy with the naked eye. It remained visible for more than 1.5 years, more brilliant than any other star in the night sky, and even visible during the day for several weeks. What secrets do these heavenly remnants uncover to us? Ancient records from various human civilizations, including Chinese and European astronomers, recorded the appearance of this new star. Interestingly, remnants of this blast, in the form of an expanding debris cloud, can still be observed today with complex telescopes, giving us insights into the violent ends of massive stars. Supernovae have been rare for observers on Earth, but imagine for a second a stellar explosion so intense that it rivals the brilliance of a full moon, casting shadows on Earth at night and even being visible during daylight. The radiation from such an event could charge our atmosphere, possibly affecting satellite operations and even the climate. Betelgeuse, with its erratic dimming patterns, suggests it may be preparing for just such a grand display. Could we be on the edge of witnessing one of the universe's most dramatic events? Just recently, astronomers made a surprising discovery. Between October 2019 and mid-2023, Betelgeuse underwent a remarkable transformation that drew the attention of astronomers and skywatchers worldwide. Known as the Great Dimming, the star's brilliance, which had been stable for centuries, began to decline significantly. This sudden change was so noticeable that even casual stargazers saw it when comparing Betelgeuse to other stars in the Orion constellation. This means that we're not only hundreds of years away from seeing its supernova blast, but maybe only a few decades, or even less. By April 2023, cosmic observations reported that Betelgeuse had returned to its normal brightness levels, leading many to believe that the period of anomaly had ended. In a stunning twist, the following months saw Betelgeuse's brightness intensifying by an astounding half. Such prominent variances, while typical of variable stars, were surprising for a star like Betelgeuse, which had mostly shown predictable luminosity cycles. The sudden and extreme surge in its brilliance pushed the star back into the spotlight, igniting discussions about its future. But what caused this sudden change in brightness? Why did Betelgeuse, one of the most familiar stars in our night sky, suddenly throw a divine curveball? Stars are not just shimmering spots in our night sky. They are dynamic entities with life cycles, behaviors, and mysteries of their own. For some celestial bodies, periodic brightness variations can be expected, akin to the rhythm of Earth's seasons. Throughout its stellar lifetime, Betelgeuse has kept a relatively consistent 400-day brightness cycle. However, with the Great Dimming, it appeared to defy its established behavior, testing our understanding of cosmic phenomena. Now, you may be wondering, are we on the verge of a cosmic revelation? While the exact reasons behind Betelgeuse's abnormalities are still under investigation, a compelling hypothesis has emerged. This hypothesis, focusing on stellar activity and mass ejection, presents an intriguing scenario. Picture Betelgeuse as a massive celestial volcano quietly ejecting and expelling vast amounts of its material into space. Recent observations from the Hubble Space Telescope revealed that Betelgeuse had recently expelled a tremendous amount of surface material into the universe. This ejection, a monumental event, was 400 billion times the mass typically released during similar solar phenomena, equivalent to several times the mass of our moon. Such events can result in the formation of a thick dust cloud around the star, affecting its apparent brightness and temporarily making it more challenging to observe. Then, as this dust began to scatter or was driven away by the star's radiation pressure, the veil lifted. This could explain its subsequent return to normal brightness levels. One way or another, these new events suggest a star that's far from done astonishing us. Many speculate that Betelgeuse may be approaching the twilight of its life, with a supernova event, a sudden burst of energy that can eclipse an entire galaxy in an instant, on the horizon. This phenomenon occurs when there is a sudden change in the star's core. Such changes can arise if a star absorbs too much matter from a neighboring star, or in Betelgeuse's case, from the exhaustion of its nuclear fuel, which overflows its mass into the core, setting the stage for a catastrophic collapse. But what drives a massive star like Betelgeuse to its end? Born from the gravitational collapse of gas within molecular clouds, stars like Betelgeuse begin their journey by consuming hydrogen in their cores. This initial phase, known as the main sequence phase, lasts for billions of years and forms the foundation of a star's life. As stars near the end of their hydrogen supply, they expand, adopting new energy sources. In the case of Betelgeuse, as the hydrogen depletes, it begins to burn helium, leading to the formation of carbon and oxygen. This transition from the main sequence stage to the helium-burning phase is marked by the star's evolution into a red giant. Over time, as helium reserves decrease, the star undergoes further expansion and shifts into other burning stages, each marked by the fusion of progressively heavier elements. The larger the star, the faster these transitions occur, given the immense gravitational forces at play. Then comes the climax, when iron begins to form in the core. Unlike lighter elements, iron doesn't release energy when fused, so the energy produced is insufficient to counteract the star's own crushing gravity. The star inflates in size, eventually collapsing and triggering a massive rebound explosion, resulting in the explosive force of a supernova. So, is Betelgeuse nearing the edge of a catastrophic end, or simply biding its time? Ongoing research by Japan's Tohoku University suggests that the star may currently be in its carbon-burning stage. Lead scientist Hawk believes the core could collapse within a few years once its carbon reserves are exhausted. But not all researchers agree. Studies from Hungary's Konkoly Observatory hypothesize that Betelgeuse is still in its earlier helium-burning stage. The one thing all scientists seem to agree on, despite these debates, is that Betelgeuse is set to become the Milky Way's next supernova. But pinning down the timing of this event remains a vast guessing game, with bets ranging from just a few years to 100,000 years. Amid these scientific discussions and speculations about Betelgeuse's future, one fact remains unchallenged: the very nature of our observations. When we look up at the starry field, there's a subtle paradox we often overlook. This paradox lies in the very concept of time and light in our vast universe. Stars and celestial bodies are so distant that their light takes an immense amount of time to reach our eyes. For example, the speed of light, while impressive at 186,282 miles per second, still has its limitations. Consequently, the light from distant stars and galaxies takes time to traverse the vastness of space before it reaches us. Looking at Betelgeuse, you're actually seeing a spectacle from 650 years in the past. To put that in context, when this light left on its journey toward Earth, the Renaissance was just unfolding, and adventurers like Marco Polo were making their mark in history. Every observation we make of Betelgeuse is like looking through a vast time capsule, giving us glimpses into its distant past. If, for instance, Betelgeuse had already exploded in a brilliant supernova, we wouldn't know for another 650 years. So, while we study and predict its impending supernova, somewhere out in the vast universe, this amazing event may have already unfolded. We're simply waiting for it to traverse the distance to reality until it reaches our eager telescopes. The recent discoveries surrounding Betelgeuse have sparked intense conversations within the astronomical community, with investigations turning to another shocking revelation. Recently observed SN 2023X, a supernova occurring in a galaxy adjacent to the Milky Way, reminded many of the fascinating dynamics and mysterious nature of the universe. SN 2023X was unique in its own right, found millions of light-years away, displaying an intense burst of brilliance that immediately outshone its host galaxy. What made it particularly interesting to researchers and casual observers alike was its uncanny resemblance to what many expect will be Betelgeuse's fate. The range, power, and aftermath of the blast offered a tantalizing glimpse into the processes that these massive stars undergo as they approach the end of their life cycles. For many, SN 2023X served as a preview of what might happen when Betelgeuse meets its fiery fate. The sequence of events might look similar to what was observed with SN 2023X. Moreover, the connection between these two celestial events highlights a larger theme about the interconnectedness of our universe. Whether it's a neighboring star like Betelgeuse or a distant supernova like SN 2023X, these cosmic phenomena remind us of the dynamic and evolving nature of space. Beyond the physical and astronomical implications, the explosion would have significant consequences for human culture. The sky, noticed and admired for centuries, would change, leading to reflections on impermanence, the immense scales of cosmic time, and our place in the universe. Such cosmic wonders remind us of the ephemeral nature of existence and our eternal journey to appreciate the magnificent. As we contemplate the potential supernova of Betelgeuse, it's essential to understand the broader implications of an event on our cosmic neighborhood. When Betelgeuse finally reaches its explosive end, it could impact not only our immediate vicinity in the Milky Way but also the dynamics of the interstellar medium. The shock waves produced by the supernova will create vast regions of ionized gas, enriching the surrounding space with heavier elements forged during the star's life cycle. This process plays a crucial role in the grand cosmic cycle of matter, fostering the creation of new stars and planets with the essential elements for life. Furthermore, the light from the impending explosion could act as a cosmic laboratory for astronomers. By studying the light curve and spectral features of the supernova, researchers could gain invaluable insights into the life and death of massive stars. Every supernova offers a unique glimpse into the physical processes at play, revealing how energy is distributed in such cataclysmic events. By studying these phenomena, scientists can refine their models of stellar evolution, contributing to our understanding of the universe's life cycle. In addition to scientific advancements, a supernova can have cultural repercussions. After all, significant cosmic events have historically influenced art, literature, and philosophy. The brilliant appearance of Betelgeuse would likely inspire a new wave of creative expression and reflection. People across the globe would gaze at the night sky, contemplating their place in the cosmos. This event could spark a renewed interest in astronomy and science, much like the curiosity that emerged during the Renaissance, when celestial observations began reshaping our understanding of the universe. From a practical standpoint, the effects of a supernova could extend to technology. Increased radiation levels from such an explosion could pose challenges for satellite communications and navigation systems. These implications would require advancements in shielding and protective technologies, pushing the boundaries of engineering in space exploration. As we continue to rely more heavily on technology, understanding and adapting to these cosmic events becomes essential for mitigating their effects on our daily lives. The supernova could also alter our perspective on time itself. The transient nature of such an event serves as a reminder that even the most monumental celestial bodies are not eternal. This realization might prompt philosophical discussions about existence and the fleeting nature of life. The universe operates on timescales that dwarf human lifespans, but we find meaning in our brief moments under the stars. As Betelgeuse hurtles toward its ultimate fate, it not only invites scientific inquiry but also challenges our perception of the cosmos. The potential for such a stellar explosion to significantly impact our understanding of space-time, nuclear physics, and the life cycles of stars is immense. The supernova event would be a natural laboratory for studying extreme conditions that cannot be replicated on Earth. For example, the compression of matter in the core of a collapsing star creates environments so dense and hot that they produce heavier elements, some of which, like gold, platinum, and uranium, are created in these cataclysmic events. These elements are ejected into space, enriching the interstellar medium with materials crucial for the formation of new stars and planets. In addition to the astrophysical wonder, Betelgeuse's demise could spark a new cultural awakening, much like the supernovae observed in the past. Celestial events have long shaped human mythology, art, and philosophy, and a spectacular explosion from Betelgeuse would undoubtedly inspire new stories, theories, and artistic expressions. This cosmic spectacle would remind humanity of the interconnectedness of all things, emphasizing our place in the vast, ever-evolving universe. It may also push us to reflect on our role in the grand narrative of existence, the brevity of life, and the enduring quest for knowledge and understanding.